Hello all. In this video, let's see about the sorting technique bubble sort. Bubble sort is actually a simple sorting algorithm that works by repeatedly stepping through the array and comparing each element with its adjacent element and swapping them if they are in the wrong order or in the wrong position. So here at the end of each iteration, uh, the largest elements are placed at the correct position. For example, at the end of the first iteration, the largest element present in the array is placed in the last, at the very last, and the second largest element will be placed in the second last position of the array, and so on. So this will be continued until the very last step. So this is what is the concept of bubble sorting. Now let us look into the examples. Here we are given an array, and that is 4, 1, 3, 9, 7, and the output is in the sorted order like 1, 3, 4, 7, 9. So in the first iteration, what happens is 4 is compared against 1. So here 4 is greater than 1. So in the first iteration, 4 and 1 are swapped. So 1 will be here, and then 4, and then 3, and then 9, and then 7. Then will be having 4 here. So 4 is again compared with 3, and 4 is again greater. So 4 will be in this position. And in the next iteration, which means this happens inside the inner for loop, and here we'll be having 4, and here it is 9. No swap because 4 is less than 9. And here we'll be having 9, and 9 is compared with 7, and we'll do a swap. So in the end of first iteration, we could see that 9 will be placed in the correct position, that is in the last position. So the same way in the next iteration, which means the outer for loop. In the next outer for loop, we'll again do the same swapping until we reach this output. So this is how bubble sort works. So now let us implement the coding part. So here we are given with an array, and in this array we need to have two loops. One is the outer loop and the other one is the inner loop. That we are going to perform swapping. We can't take up to from the very first element of the array to the last array, to the last element present in the array, because if we take the last element directly, we will not be having any other elements to compare that last element with, right? So we are going to take from, like, for int I is equal to 0, which means from the first element to I less than n minus 1. So if I take n minus 1, I can compare this n minus 1 with the next element, that is nothing but the nth element, right? So that is the reason why we take n minus 1. And this is the outer loop, which will iterate through, like, in the uh, at the end of this uh, outer loop, we will be having that one element that is placed correctly in its position. That is nothing but the largest element. In the inner loop, we'll be having all the swap operations and comparisons. So for int j is equal to 0, j will be less than n minus I minus 1. I'll tell you why this is n minus I minus 1. See, in the end of this outer for loop, we'll be correctly placing the largest element in its position, right? So there is no need to compare them again. There is no need to swap them again. So that's waste of time. So in such case, we are including this I here, which means I'm not going to disturb those elements that are placed correctly at the end. So as the elements are sorted, like they'll be correctly placed at the end only. So from the end we'll be having the correct order. So that is why here we have mentioned n minus I minus 1. See, for example, in this case, at the end of first iteration, 9 will be correctly placed in the last position, and my I value will be 0 in the first iteration. So j is equal to 0, and j will be less than n, which is the size, minus I is nothing but the 0 which is the current I, and then minus 1. So it will be n minus 1, which means I'm not going to disturb the n minus 1th element, that is 9. I'm not going to disturb the last element. That is the reason why we are mentioning j is equal to 0, j less than n minus I minus 1, j plus plus. These are the two loops. So the one thing that I'm going to check is if the current element, that is nothing but j, if the current element j is greater than its adjacent element, which is nothing but j plus 1. If in this case, if array of j is greater than array of j plus 1, then I'm just going to do a simple swap that we already know. So temp will store the value of array of I, and array of I will store the value of array of I plus, sorry, it's not I, it's j. Yeah, it's j. Array of j will store the value of array of j plus 1, and array of j plus 1 will store the value of 10. So this is the normal and simple swap operation that we are going to perform in bubble sort. And this is the logic that we have applied. Now let us compile this. I get an error. Okay. Since I haven't mentioned n, what is n? So n is nothing but array dot length. The length of the array is n. Okay. Yeah. It's compiled successfully. Now let's just submit this. Yeah, so test cases are passed successfully. So this is how we implement bubble sort. Thank you.